Thank you so much, MK. And we have our final leader talk from Alana, who is a USask Schulich leader from 2016, and she'll be graduating in 2020 in environmental biology. So please join me in welcoming Alana.
Science is sturdy when it has a purpose. Why does your science matter? Does it address a real-world need? Contribute knowledge? Or alter understanding? What makes your science stable? As in nature, and when you're making sturdy furniture, you require either 3 legs or a very wide base. Science should too. So 2 things make my ecological work sturdy: relevance and interdisciplinarity. Sustainability is inherently relevant and interdisciplinary. It simultaneously addresses environment, economy, and equity. It acknowledges that humans are a part of nature rather than apart from nature. It gives us clues about who we are and what we need to understand in order to solve a problem. So to illustrate, I'll look at a local, international, and national example. So the Cumberland Sound beluga is a unique Arctic subpopulation in the Canadian Arctic of around 1,100 individuals, and it has threatened status under Canadian law. So current population recovery recommendations do not include a complete ban on hunting. Rather, they support a quota of 41 individuals per year, despite that resulting in 30% lower population density and a recovery time of 90 years. So why would ecologists advocate a quota rather than an all-out hunting ban? Because a quota is the best means of protecting this beluga population and the Inuit community that is relying on it. So in this case, interdisciplinary analysis leads to broader policies. Protecting this beluga population requires that we support Indigenous engagement, preserve the Inuit way of life, restrict commercial fishing, reduce pollution, address climate change, and fill knowledge gaps. So the second case study concerns South Korea's Arctic policy. So Korea is outside of the Arctic Circle, yet it has a high stake in the Arctic. And the key motivator being that Korea's economy is dependent upon trade. So barriers between North and South Korea mean that South Korea is ostensibly an island, and the Arctic offers a 30% shorter shipping route to Europe. So trade interests are driving Korea's polar activities, which include environmental research, technological development, Indigenous advocacy, public education, and Polar Council membership. So the Korean Polar Research Institute, COPRI, undertakes climate and sustainability research in both the Arctic and the Antarctic. And Korea's high-tech ships facilitate polar research at both poles, and they have a ballast-free design that leads to lower contamination of those regions. And Korea supports public research institutes and education initiatives, including the Korean Arctic Academy, which I attended this summer, and also Arctic Indigenous rights and advocacy. So in this case, interdisciplinarity matters because combining economics with equity and environment widens Korea's focus and deepens its concern for impacts within and outside its borders. And factors like climate change and indigenous issues inform Korea's scientific research and affect its policy. So the third and final case study is about Saskatchewan grain farms. So in this region, intensive agriculture limits biodiversity, yet grain farms provide income and support to rural families. So about 5 times more of Saskatchewan's land is cultivated than the Canadian average. Yet there are many wetlands throughout the province, and those provide ecosystem services and can enhance biodiversity within croplands. So biodiverse landscapes support watersheds, ecosystems, and ultimately economic resilience. There's some important connections driving this. So farmers' security and profits lead to increasing non-crop farmland, which also increases nature's ecosystem services, and in return, increasing farmer security and profits. So in this case, interdisciplinary matters because including social and economic analysis along with environmental analysis improves improves policy and science. So farmers are implementing strategies that are based on sturdy science research that allows them to achieve their ecological, social, and economic goals. So does or could interdisciplinary approaches widen and deepen our understanding and make our science more sturdy?
Do we have any questions for Alana?
Yeah?
In regards to the environment and climate change, what steps does Canada need to take to ensure that it will meet its 2030 commitments?
Yeah, so there's lots of different ways we could go, obviously. Some of the important ones are in Saskatchewan are like reducing the loss of wetlands in farmland because wetlands provide ecosystem services, which can lead to reductions of the inputs put into farming. So there would be less fertilizers, less vehicle emissions and things. So there's that. And then there's also the fact that wetlands are storing a lot of carbon, way more, about, I think, double the amount that the carbon capture technology Brad Wall was working on before does. So they're really important for multiple reasons. That's kind of an area that some of my research has been around, so I know a bit about it. But just looking at farming practices and making sure that things we're doing for climate change are still leading to profits and to agriculture output. And there's many ways to do that that include lowering pesticide use through implementing different biodiversity practices and just looking at ways to use science to improve farming that in a way that also improves climate actions. Yeah.